Hello grade 11s, and we're looking at exponential functions. So let's look at this exponential function, which is our most basic one, using our general form y equals a times b to the x minus p plus q. So the only new bit is this p part right over there. Yeah. So we know what the others do, but let's run through just to remind ourselves. If we're given this function, and let's make a, as we can see, way across there somewhere, a is, there it is, a is 1, we're not going to add a p, and we're not adding a q either. So we've just got the most basic function here, y equals 2 to the power of x. What does it look like? Well, there it is, it goes up and it rises exponentially. It's got the y-intercept down here at 0, 1, because, well, if we go 2 to the power of 0, that's 1. So then y equals 1. That would be our y-intercept. And we've got an asymptote here at y equals 0, because as we get more and more negative, it gets closer and closer and closer, but it will never quite reach 0. So that's our asymptote. Okay, so let's play around with some things. Let's start with our a value. So if our a value increases, then just like the parabola and the hyperbola, it just stretches it out a little bit. So let's do it and let's see what happens. So we drag it here and we say, cool, well it stretches. So let's go for a equals 10. Now let's look at our function here. So we've got 10 times 2 to the x. Well, if it's 10 times 2 to the x, well then to work out our y-intercept, which is now at 0, 10, let's see how it work that out. Well, we'd substitute in and say, well, x equals 0 for our y-intercept. So 2 to the 0 is 1. 1 times 10 gives us our y-intercept. Nothing else changes. We haven't moved it up and down. We haven't moved it left and right. Okay, so that's what our a value does. What do you think the function would look like if we had a negative a? What did the negative a do to the parabola? What did it do to the, which way? What did it do to our hyperbola? Okay, so we know what a negative a would do. Let's check and confirm. So let's make a negative. There it is. So a equals negative 10, for example. Well, all it's doing is it's reflecting it about the x-axis. Everything else stays the same. Asymptote's still there. Our y-intercept is obviously just gone from positive 10 down to negative 10, but we've just reflected it because that's what our negative a does. So let's put our a back at 1. So we're just multiplying by 1, in other words, it's just 2 to the power of x. And let's deal with q. So the last bit here is q. What happens when we add a value at the end? So we can add a positive or a negative. Well, we know from parabolas what happens, and we know from our hyperbolas as well what happens when we add. That's our vertical shift or our vertical translation. So let's add in a q and say if we made our q value and we added 7, then the entire function is just moved up by 7. So our asymptote was sitting down here at 0, now our asymptote's gone up to 7. There it is, y equals 7. So that's our asymptote. Our y-intercept was sitting, where was it, about there at 0, 1. So it's gone up by 7, it's now sitting at 8. So everything just moved up by 7. And if we're sketching this function, draw that asymptote first. It's the first thing to do, just like with our hyperbola. Okay, and if we had a negative q value, let's go for negative 11. Well, then the whole function has shifted down by 11, and notice that we've now got an x-intercept, so you'd have to determine what that is. How would you work it out? Well, you know the y value is 0, so sub in and you'll get your x value. Okay, so let's put our q value back to 0 and say we're not moving it up or down at all. So only the new thing that we're doing now is saying, what does our p value do? So our p value is hidden all the way over there, and it's now x minus p. Now think about the parabola. When we had, say, x minus 2 squared, did it move left or did it move right when we had the minus 2? And with the hyperbola, if we had x minus 2 in the denominator did it move left or right? Remember, it kind of moved the opposite to what we expected. So it had x minus 2 meant that it moved right by 2. Let's see what happens here. So if we've got a q value, and no, that's our q value, our p value, and we said let's go x minus 2. So what's our function done? It's done as we've expected. It's on the opposite of what we kind of expected, in that it's minus 2, so therefore it must have moved right by 2. And I'm going to just drag this a little bit just to show, look, as we're moving it there, as we're going x minus 11, for example, then so we've got x minus 11 up here, then the whole graph has shifted to the right. And likewise, if we had x plus 11, then the whole function is going to have shifted to the left. So let's throw that in there and go, well, there we go. As we put that in, it does, as we were saying, kind of the opposite. So if we threw that all in together, and let's choose a value of a, let's go for negative 4, leave our b, p is 6, and our q, let's move it up there to 8. And we're given this function. So we're given this function over here, and we said we've got minus 4 times 2 to the x plus 6 plus 8. How would we sketch that function? Let's just run through the steps to go, okay, well, we've got a negative a value. So if we've got a negative a value, we already know that it's reflected about the x-axis. And there we can see that shape now is going down instead of going here and going up all the way. As it's coming along, it's going down. Okay. Then we've got this plus 8. So that means that everything's moved up by 8. And we can see it. Look at this asymptote here is now sitting at y equals 8. So we already know that our function, if we drew it, we're coming here and it's going to go down like that. And that's what we could have drawn already. And then gone, oh, great stuff. Looks like there's going to be an x-intercept now. How do we determine the x-intercept? Well, we'd substitute y equals 0, substitute it into the equation, and you'll get your intercept. I think there's going to be a y-intercept here. Well, let's have a look. Looks like there might be one way down here. And there it is. So if we zoomed out and saw our function, there's our y-intercept all the way down there. How do we determine what our y-intercept is? Well, there's one thing we know. We know the x value is 0. So we just substitute it in to get our y value of negative 248. Okay, so that's exponentials, except for one last thing, and that is, this is all well and good when a was a value like 2, or, sorry, if a were 2, then that's great. If b, this value over here, this 2, if this one were 2, 3, 4, 5, our function's going to look the same. Not much is going to change. It's stretching it, it's looking a little bit different, but not too bad. What happens if that's a fraction though? So let's drag this and say, let's make this some little fraction and make it a half. So that's often the case. So now we're going to take everything else as it was. 1, let's not move it up or down. Let's not move it left or right, up and down. And so if we've got a fraction over here, so if we've got this part here is a fraction, and it's never going to be negative, but if it's a fraction, then the shape of our function is going to come in and it's going to get smaller as we go along. So we can see starts up there and it goes down and gets smaller this way. So it comes down and it gets smaller, so it looks different. It's reflected about the y-axis, so it looks different to these functions here. So if we've got a value up here that's bigger than 1, then that's what our shape's going to look like, going up. And if this value here is a fraction, it's going to have that opposite effect, and it's going to come here and it's going to go down. Okay, so there's our revision of what to do for exponential equations. I want to jump on, I'm going to make one more video where I'm going to take that example that we've done here and actually sketch it step by step, not just saying, well, you would do this and do it weatherman style here, but I'll go through it step by step so we know what to do. Yeah, I hope you enjoyed that. I had fun here with the screen.